Okay, so so we were about to discuss about the changes in heat in case of an endothermic reaction or exothermic reaction, and we will also examine if there is any change in the heat or not. Okay, so let us write down the equation first. Okay, reaction CH4 plus Cl2 CH3Cl plus Cl2. Okay, is the reaction balanced? First of all, tell me.
No. Actually, yeah, no.
It's not
No.
balanced.
No, it isn't.
Okay, so we have to balance it, right? So let's see how can we balance it. So the let's try to balance the amount of hydrogen, right? Amount of hydrogen. Um, amount of hydrogen. 3 here, 4 here. Okay, let us multiply with 3 then. So 3, 3, minus 4. Oh, why am I multiplying? 3 carbons, 4 carbons. No, it can be. 1 second. It shouldn't be like this. 1 second. Actually, there is a particular thing missing here. That is, while forming this reaction, hydrochloric acid's presence is also seen, and the reaction here is called like, what can I say? See this CH4. From this CH4, for each and every step, you will see that hydrogen is being replaced with chlorine. Okay, so one chlorine comes here and one hydrogen gets released. So I think it should be HCl. Let me just check. 1 second. I don't think this is the correct reaction. What? CH4 plus Cl2 CH3Cl plus Cl2. How is that even possible, man? How is that even possible? One more CH bond and one more Cl bond has been broken, and one more HCl bond has been formed. Don't we need to? We have to do balancing. Okay, CH4, CH4. Okay. Let's. I think. Okay, first of all, let's do this, and then we will think about like the balancing of the equation. Okay. First of all, let's perform it. Okay. See CH4. Okay. Let us write CH4 like the CH. Don't look at what the book has said. You should do in this way. Okay, this is the way which will give you the correct answer, and the probability of messing up will be like tends to 0. Okay, Cl. Let's see. Okay, now see in the left side, what have you got? We have 4 CH4 bonds, right? Sorry, 4 CH bonds. Is that correct?
Yes.
And 1 Cl bond. Okay, so the energy of reactants equals to CH is 414, right? Yes, CH is 414. So 414 multiplied by 4 plus ClCl. ClCl is given with, they haven't given ClCl. Okay, actually ClCl won't be needed because ClCl will be cancelled out as well. Okay, see, ClCl and ClCl will cancel each other out. So for instance, say for ClCl we're considering X. Okay, right. Understand my point? ClCl, the bond energy of ClCl on both the sides will be X. Okay, understand my point?
Yes.
So X and X will cancel each other out. Okay, so energy of products is equals to 3 HC is CH are 3, right? 1, 2, and 3. So 414 multiplied by 3 plus CCl. We see a CCl. See, there is a CCl. Okay. Now, can you see it more clearly, I guess? So
Yes.
CCl is 244. Okay. 244 kilojoule per mole. Okay. 244 kilojoule per mole. Okay. And plus X. Okay, so now, okay, one second, I'm receiving a call. Okay, sorry about that. So where was I? All right, so let's calculate now. So delta H will be equal to total. Have I unmuted? Okay, yes. Total energy of products minus there has to be an HCl. I don't understand what you're trying to say. See, it's gotta be an HCl, you know. I mean, there are 4 hydrogens, there are 3 hydrogens. Okay. I don't know. Okay, let's check. I think there's something wrong with this math. Total energy of because we cannot work with unbalanced equations. Total energy of products minus total energy of reactants. Okay. So after the calculation, what do we get? Let's see. Let's see what do we get. For 14 into 3 plus 244. 1486. 14 into 4. 1486 minus. Okay, see, this is somewhat like minus 170, which is not correct. Okay, so there is something wrong, as I was saying. Okay, just a second, give me a second. Let me check it out. What is the problem? This reaction is obviously not correct. Okay, that is the thing I could say. There is a hydrochloric acid somewhere. Okay, let's see what they have written. Okay, have you taken notes of this first of all?
Yes.
You have understood the procedure, right? If this is the
Yes.
reaction given, then this is the procedure. You will calculate the total energy of the reactants and total energy of the products, and then you will just minus them. I hope it's now easily understandable, like not like before. Okay, but this equation is not correct. I mean, we cannot do it like this because the number of chlorines is not correct in both the sides. The number of hydrogens is not correct as well. So let's see what we can do. What they said. Okay, can I erase it?
Yes.
All right. So they have said that in the equation, 1 mole CH bond and 1 mole Cl bond has been broken. Okay, other CH bonds remains the same. I have no. Okay, and has been broken. Among there's while 1 mole HCl bond has been formed. Okay, so now I understand. Okay, so you see this Cl2, this will be HCl. Okay, this will be HCl. That is what I was saying. This will be HCl. This won't be Cl2. Okay, this will be HCl. Okay. Why am I saying that? See, if it is HCl, what will be the amount of energy of the products? Tell me. In that case, one second, just okay. Let me get back to
All the products.
1 second.
That would be 1486 plus X.
Okay, let's try again. 1 second. All right, and also the chlorine's bond energy will be needed now because we don't see any chlorine bond now. So let's see chlorine's bond energy. It's 244. Okay, this is not even CCl. What is wrong with them? I just don't understand. What have they done? Okay, what is CCl? Just let me check. CCl is 326. Okay, we write down CCl is 326 and CL is 244. CCl is
Where? Sorry,
326.
hold on.
Okay, 1 second.
CCl is
326.
okay.
CCl 326. If you find mistakes in books, that is not very pleasant thing to see. Okay, 244. Okay, and also obviously kilojoule per mole. Okay, so in case of CCl, it was wrong. Okay, let us start from the scratch again. Okay, say I'm writing all of it again because you have to have clear idea about this. You cannot be confused. So 414 kilojoule per mole for CH. For HCl, it is 431 joule per mole. Okay. All right. Now CH4 plus Cl2, CH3Cl plus Cl2. Okay. Very good. Now in the left side, as previously we did, CH, H plus Cl, Cl, and then you will get CH, HCl, and sorry again I've written it's HCl plus HCl. Okay, so total energy of reactants. Okay, reactants equals to CH is equals to 414. Okay, 4 multiplied by 414 plus CL is 244. Tell me the value of this. What will be the value of this?
Uh,
I don't have a calculator with me actually. I'm used to mobile. Do you have a calculator? Okay, 1 second. So
yes.
it's 4 into 414 plus
1955. It's a good song.
9.
Oh wait, no, is it 244 or
Yes,
299?
244.
Oh, okay, sorry.
It's
I got
1900, right?
confused. 2199, yeah.
21.
No, wait, sorry. Hold up.
It's 1900. Okay. You have to
Yeah,
be careful
1900.
while using the calculator. Okay. And total energy of products will be equal to 3 multiplied by 414 because we can see 3 CH bonds. Okay. Plus 1 CCl bond, and CCl bond is 326, and 1 HCl bond as well, which is 431. 431. Tell me the value of this. This is 1999. Okay. 1999. Now it makes sense. They have just worked on the answer and they have just written down the equations in the wrong way. They have given wrong information as well. Okay, now it makes sense. Now delta H will be equal to delta H is equals to reactant minus product, right? Or I'm okay, yes. Reactants minus products. Yes, reactants minus products, right? Or products minus reactants. Products minus reactants or reactants minus products, whatever. So it will be 1900 minus 19. Can you check the formula that we wrote down for delta H? Total internal energy of
Total energy of product minus total energy of reactant.
okay. So then it will be 1999. Okay, 1 second. Another thing here we have to check. 1 second. Total. Okay, another formula you have to write down. Okay, delta H equals to this one. Okay, you will need this one. The total bond energy of reactants minus total bond energy of products. The previous one was the internal energy. Okay, internal energy and bond energy is not the same thing. We are as we are working with bond energy, so we need to understand the formula with bond energy. Okay, so the total bond energy of reactants minus total bond energy of the products, which may imply that total energy required for breaking the old bonds minus total energy released in the formation of new bonds. Okay, so take a note of this, it's very important. So after doing all of it, we will get the answer to a minus 99 kilojoule per mole. Minus 99 kilojoule per mole. Okay.
Done.
Okay, very good. All right. Sorry about like this wrong math, but I hope you have understood how to do this math. Okay. I was not being able to find any maths. But in case of your examination, you will get these sorts of maths. Like one equation would be given, and there would be tables with like the bond energies, and you have to like draw the structural formulas, and then based on that, see what bonds are there, and based on that, you have to multiply uh, by that particular bond and calculate how amount of energy is released or being absorbed. Okay, let's see what your book has written. Good. Single page. Okay, fit width. All right. Exothermic and endothermic reactions. We have already in exothermic reaction, energy is released, and while in endothermic reactions, energy is absorbed. Okay, specific heat capacity. Okay, this thing. Okay, this is a very interesting thing. We will study about that in the next class. Okay, we studied this in physics. Okay, at 9th and 10th standard. This is the like what can I say? The principle of calorimetry. Okay, calorimetry. Okay, very interesting thing. Calorimetry. We will study calorimetry. Right, not a difficult thing in particular. But what about bond energies? Aren't those present? Okay, it's only that much. Okay, so there's nothing actually. So the next day we can complete in within 10 minutes. Okay, and okay, so today is 9th, right? Okay, Sunday. I have my exams on 16. That means I won't be available for 13. Not, I'm not saying that I won't be available. I don't want to be available actually.
Ah,
That way. 13, 14, 15. Okay. So I will take full break and we can study at 16. All right. But
okay.
at 16, again, I guess on 20. So that means it's better if we, and then I have exam on 26. So in between, I can manage some time between 20 and 26. But it's better within 12 if we can manage. We have got taken 5 classes. Okay, can you give me time on 11th? That is 11th. Is it possible?
Yes.
11th Tuesday.
Yes.
At what time? Is it possible in the morning?
I'll be home by 2:30. So that'll be 10:30 at your time.
So 11, right? Is 11 possible or is it 12?
Yes, we can do 11.
Okay, 11:30. I think it will be better, I guess. 11:30 a.m.
Okay.
or it's going to be 3:30, right? 3:30 p.m.
Yes.
That is 11th of October. Okay, 11th Tuesday. All right, see you then, and thank you so much for joining the class within such short notice. Okay.
Oh, that's all right.
All right. Okay. Allah Hafiz.
I love this.